Thank you so much for coming back today at our channel, The Physics Mindset, the only channel to give you electrical installations, electronic repairs, and solar engineering. Now, since we have seen about the atomic structure, about electrons, neutrons, and protons, now we saw how electrons react in a cable, that is the atoms, the atomic structure which we saw. If you apply voltage to an atom, electrons move and produce electricity. Okay? Now, we are still striving to go forward and understand this electricity from the bottom, from the foundation to the top. Today we are going to study about three major materials, the important three materials in electrical engineering. Without these materials, electrical engineering can't exist. Okay? And these materials are the conductors. This is what we're going to cover today. The conductors, the insulators, conductors, insulators, and semiconductors. These are the three major materials we use in electrical engineering. Okay? All components you see in electrical, in electronics, in solar, their fundamentals came from these, the conductors, the insulators, and the semiconductors. Okay? We're going to look one by one and we see what it means. Okay? As we, the beginners in electrical engineering, or electricians, or solar installers, we need to know about these three materials before we go far in electrical. Now, today let's start with the conductors. Conductors. Remember these words. As the word, these are the terms we're going to be using in your field, electrical. If you're an electrical engineer, if you're a solar installer, or electronic repair, those are the technicians. These are the words you will be using in your fields. Conductors. Conductor. As you see a conductor. Now, what do they say? What is this material, the conductor? These are materials that allow electric current. Listen very well. That allow electric current to flow easily because they have many free electrons. These are materials that allow electric current to flow easily. Electric current to flow easily because these electric currents have many free electrons. You remember electrons, what we said on electrons, that on the outer valence electrons, once you apply the voltage, these electrons will move. And once they move, they produce what we call electricity. Okay? And we have given one of the examples of these materials. There is copper wire, this copper wire you see. There is aluminum, okay? There is silver, okay? There is also gold, and among others. These are the materials which are conductive, which have free electrons, which allow electricity to allow freely and easily. Electricity passes through them. Let's say this is the conductor, this is the wire, this is point A, and point B. So if electricity is passing through, if you apply the voltage, okay, let's say this material is the copper, okay, or aluminum. Let's say it is copper. Now, if you apply voltage into this cable made from copper, this cable, electricity will pass through. Electrons, this cable copper has free electrons. Electron will move because of the pressure the pressure, the voltage, which is the pressure to push current or to push electrons. And once electrons flow in a cable or in a conducting material, which we said it is a copper, we produce what we call electricity or electric current. And at point B, we shall have an electric current. Okay? And this is our copper, an example, just an experiment. Now, we have come to see that conductors are used in electrical wiring. You see the use of the conductors? Conductors are material which allow the flow of electrical easily, because these conductors, this copper, aluminum, have free electrons in them. Once you apply voltage in them, electricity will pass through easily. Though they have some resistance. These aluminum, silver, gold, copper, they are good conductors of electricity. And these conductors are used in electrical wiring. Okay, now I want to illustrate for you something small on this conductor when you apply voltage, because it is a good material that allow electric current. Now check. This is a conductor. Okay, let's use this one. This is our conductor. Okay, these are cables. Hope you're seeing them well. This is a conductor made of copper. It's a copper wire. One of our example. Now, this conductor once you apply electricity here, a voltage, at the last point, we shall have electric current. Now, once you apply voltage at one point, voltage here inside the conductor, there will be electrons moving. Inside the conductor, there will be electrons moving. Okay? And these electrons, the moment they move, depending on the force on the voltage applied, these electrons will produce electricity. And that is why we use them. These conductors, that's why they are used in electrical wiring. Okay? Because on electrical wiring, we are going to light our lights, our TVs, our sockets, switches, when there is a source of power. And once you apply the source of power, electrons will move in these cables because they are made of copper. I told you copper is good conductor in wiring. Okay? When you're doing wiring, it's good. And even power cables. These are one of the power cables. A power cable, like you see this. This is a power cable because you plug it into a socket and it will supply power to your gadget or a TV or radio or DVD. Okay? A power cable. Another type of power cables you will find on the grid. We shall go there when we are in generation. Okay? Now, also it is used on the bus bars. Bus bars are in the, you see, distribution board. In the distribution board, we shall have, it is like this. This is the distribution board. Bus bars are where you put your Your circuit breakers, it is one bar like this. That is a bus bar. And you connect your circuit breakers. 15 amps, 5 amps, 30 amps, okay? 25 amps, okay? And this bus bar is the one which is connected on the live, let's say if it is live, because circuit breakers are connected on the live bus bar, so that they supply to the circuits you have connected, either light circuit, either power circuit, that is the sockets, or cooker control unit, or any supply you wish. And this bar is the one we call the bus bar. And even there is where you connect your neutral points, and this where you connect them, it is the bus bar, a neutral bus bar. Okay, then you bring your cables, you connect on those neutral bus bars, neutral bus bar. There is also a bus bar for earth, still in one distribution board. There is also a neutral bus bar. Earth, this is for neutral, this is for live. And you will connect your cables on the earth bus bar. Okay? And this is how these bus bars are found in distribution board. Either some people call it main switch inside the houses, or distribution board in the buildings, commercial buildings. Okay? We have seen another point that these conductors have low electrical resistance. These conductors have low, these conductors, you see, it is a copper conductor. It has some resistance within it. Okay? Now, this resistance, it opposes some flow. You know, wherever you see any word resistance, just know resistance is equals to oppose. Oppose the flow of electricity or the flow of electrons. When electrons are flowing, there are some resistance. Though they are flowing freely, though these materials, though it is a conductor, and it allows electric current to flow easily, even though it is flowing easily in the cable, even though power is passing through the cable. But because of the properties of copper, there are also resistance, but small resistance. Okay? That's why we have said conductors have low electrical resistance. Copper has resistance. Aluminium has resistance. Silver, gold, every material has resistance in it. Though power or electrons will still move through it. And since it has low electrical resistance, electrons will continue moving through the cable. Okay? Electrons will continue moving and it powers our gadgets. Okay? And this is how conductors are used in our electrical field. You need to know the conductor, the conductivity of a cable before you start wiring. Let's say in solar, the good conductor to use is aluminium because it has low, very low resistance. And since we are using the battery, so that we don't want to utilize all the battery at once in short time, we use the one which is having very low resistance. And we don't use big cables when we are wiring a house using solar system. It is good unless when you have applied an inverter, whereby an inverter will change the power from chemical from DC into AC electrical. And that is where you will need copper wires to wire your house. But once you're using a DC to wire a house, please look for aluminum cables, small cables, will pass and they will have little resistance, whereby you will not have high voltage drops in the cable when you're dealing with solar system. Okay, these are the difference. When you're dealing with electrical AC, alternative current, always use copper, pure copper. Its conductivity is good on AC. But when you're using a DC, a battery, always use aluminum. They are good because it has low voltage drops in the cable than a copper. When you're using a copper in solar systems, you will lose a lot of voltage drops. And remember, we're using only the battery. Okay, our supply is limited, which is the battery. But once we are using an AC, alternating, it goes, it comes back, it goes, it comes back. Okay, now it is good for copper but not aluminum when you're using AC. But when you're using DC, always use aluminum. Okay, now since we have known the conductor and its use, good for electrical wiring, power cables, they are good in bus bars, in the distribution board. Okay, because they are copper, very efficient to carry the heavy electrical. Now, and these conductors also have low electrical resistance. Now let us look on what are insulators. What are also insulators? Since we know now, we are moving and we know now the conductors. Let us also learn small thing about insulators. Okay, since we know now the conductors and we know that it is good for electrical wirings and it is some material which allow the flow of current. Now, insulators, we are saying insulators are the materials that resist the flow of electric current. E.g., for example, a rubber resists the flow of current. Plastic resists current, can't pass through plastic. Okay, glass, current can't pass through a glass, or electricity can't pass through glass. A dry wood, current cannot pass through these insulators. These are one of the examples of insulators: the rubber, plastic, glass, and dry wood. Insulators these are the materials which resist completely. They resist completely. Current or electricity can't pass through them. If you put an insulator and you connect electricity will not move, will not pass, will not flow, or electron will flow through an insulator. Like a rubber, electricity can pass through a rubber because of the high resistance, very, very, very high resistance to the flow of current. Plastic, current can't pass through plastic. Now check. This is an insulator. This is a cable. I think everyone knows about this cable. You see, this is a plug, and this is a cable. A cable which is having, check, there is a black on top, which is the rubber. This is the rubber. There is cables inside, but these cables are insulated in blue rubber and brown rubber. Okay, hope you're seeing it very well. And on top of them there is a black rubber still. These are high insulations of electricity. They have high resistance of electricity. Electricity can't pass through a rubber or plastic or a glass or a dry wood. Electricity can't pass. There are very many insulators which we use in electrical, but these are the major ones. The rubber, as I've showed you, this is a rubber, plastic, dry wood, okay? And we have seen that these insulators, since they have high resistance to the flow of current, meaning whatever you do, and if you put an insulator, current cannot pass through. Whatever current, okay? Check this. They have very high electrical resistance. These insulators have very high electrical resistance. These ones, these insulators, they have very high electrical resistance. Electrical can't pass through them. They protect people and equipment from electric shocks. They protect people and equipment from electric shocks. These cables, these rubbers, protect people from getting electric shock. If I plug this into a socket, and if the cables were naked, I will experience an electric shock. But once they have we have our rubbers on, once our cables are insulated with these rubbers, we can't have an electric shocks. That's why we are saying they protect people from electric shocks. And even our equipment, some equipment need insulation so that they don't contact to get either short circuit, okay? Another point, we are saying that insulators are commonly used to cover electrical wires and support transmission lines. Whereby, how does it support transmission line? Let us see. Check here. In our transmission line, we said dry wood are insulators. Rubber, plastic, glass. Now, if it is wood, transmission line, we have the pole. This is the ground. And another pole here. We are transmitting our power from one place to another. Here, we first put insulators. These insulators, then you put a conducting material, the cable, and we put an insulator which is connected to the pole. Okay? This cable is not directly connected to the pole when you are transmitting. An insulator first, then a wire, then an insulator to the pole. And this pole is wooden, dry wooden, which acts also as an insulator. And before connecting the cable, we have the insulators. Okay, meaning these insulators are commonly used to cover electrical wires and support transmission line. They support transmission line. These poles are insulators to support the transmission lines. Okay, even to cover electric wires. This is the point which I was telling you. You see, they cover. This is a cable, okay? A cable which is having an insulator on top and is having a cable, okay? This is a cable, a conducting material of electricity, and it has insulator. It has an insulator on it, and it has another insulator on top to protect or to cover electrical wires. We use insulators and we are free with it, and power will be passing through inside the conductors when the insulators have covered the cables, and that is one of the use of the insulators. Okay, so now, since we have seen also, we have known a bit of insulators, conductors, we have known the conductors, we have known the insulators, and we need to know what are semiconductors? Semiconductors, what are they? We are driving our things slowly. We are going where we want in electrical engineering. You can't miss this if you want to be a true electrician. You need to know a conductor, you need to know an insulator, and you need to know a semiconductor. Because semiconductors, where we are heading in electronics, we shall need to use a lot of semiconductors in electronics. Electronic repairs, you will have to have this information with you. And in electrical, you can't start electrical without knowing the conductors, the bus bars. Okay? You can't know electrical without knowing the insulators. These insulators, the one which are having high resistance on the flow of current. Because it is, as we said, they protect people and equipment from electric shocks. Now, once you don't know insulators, you will have electric shocks all the time. But once you know what it tells about insulators, you will be prevented against electric shocks. And let us jump and talk about the semiconductors, just briefly, and so that you understand technically, and we jump into another topic. Let's see the semiconductors. Semiconductors these are materials that have electrical, listen very well, these are materials that have electrical conductivity between conductors and insulators. Wow. These materials, semiconductor materials in electrical engineering, these are materials which have electrical conductivity between, they have electrical conductivity between conductors and insulators. Now, in between there are some electrical conductivity, and it is semi, either this side or this side, semiconductor materials. Okay, and this thing is we are going to use this information mostly in electronics. Okay, check. Their conductivity can be controlled by adding impurities, and this process is called doping. Doping is the process of this conductivity, either a conductor and an insulator, to have some electrical conductivity. The process to mix them, to mix an insulator and a conductor, that process is called doping. It's called doping. Or by changing temperature or light. Check this. Let me give you some small explanation by using an experiment in theory, but it will be a practical way. Now, if you change by changing a temperature or light, let us say, do you know about solar street lights? I hope you have the video with you about the solar street light I gave you. Now, these solar street lights, they have what we call light dependent resistor. A resistor which depends on light. Remember, a resistor, that is the resistance. A resistor, it means you are talking about resistance. Now, when light comes, let me give you a small, this is the sun, okay, and this is our solar lamp, okay, which gives light down. Okay, these are the light. Now on top here, on the solar lamp, some solar lamps, they have light dependent resistor, light dependent LDR resistor, and we have our solar panel. Okay, this is the pole, this is the bulb, this is the solar panel, this is the battery, and this is the street. This is a solar street light. Now when the sun hits, the sun will hit the panel, and the panel will charge the battery. Okay, that's the principle. Now at night, who switches these lights on? No one. They switch themselves. Okay, when the sunlight comes, the sun rays hit the light dependent resistor. Light dependent resistor, when the sun comes in the morning, the resistance increases. Light dependent resistor is connected with the circuit controlling the light, the LDE, the LED light or the LED bulb, okay, on the street lights. Once the sun hits the light dependent resistor, the resistance increases. Okay, and once the resistance increases, it limits the flow of current from the battery. And once the flow of current is limited or it is resisted, the bulb will switch off. Okay, or the LED light will switch off. No one switches them off. It is by the principle of changing the light, okay, or temperature. So now when the sun goes when the sun goes in the evening at around 7 p.m. okay, the resistance of the light dependent resistor, the resistance decreases or comes small. Once the resistance comes small, current will pass through and our light will switch on. Hope you're following this principle well. When the sun is there, the resistance increases and the resistance limits the flow of current from the battery to the light, and the bulb will switch off. That is in the morning, let's say 7 a.m. when the sun has come out. And in the evening, when the sun is moving out of the place, when we are having the darkness is coming, the resistance of this light dependent resistor decreases, and once it decreases, it allows the flow of current to pass through from the battery to the LED light bulb, and we shall be having our light here at night because of the low resistance from the LED light dependent resistor, because there is no sun. And once the sun comes, the resistance increases, the bulb will switch off, and that is the principle. And that's why we see once you change the light, and it comes to be, it is either a conductor, it acts as a conductivity, or a conductor which allow the flow of current. Again, it changes to be an insulator when the sun is there. It acts as an insulating material to limit the flow of current, and this process is called doping. Okay, let's continue. One of the semiconductor materials, we have the silicon material and germanium. These are materials which are, let's say, in silicons it is used in electronic components. Okay, even in solar system, as we are seeing here, semiconductors are used to manufacture diodes. These semiconductors are used to manufacture diodes because they have diodes are used to manufacture from silicon or germanium, mostly silicon. Diodes. Those are electronic components. A diode allows the flow of current in one direction, and once you change it like this, it has high resistance to the flow of electrons, meaning it acts as a conductor when connected in forward bias direction, and once you connect in back bias, it doesn't allow the flow of current. Okay, that is the diode. And it depends which type of diode. There are types of diode, Zener diode, okay, we shall see when you reach in electronics. Now, these conductors are also used to manufacture transistors. You see, as I told you that semiconductors, we are going to need it when we are dealing in electronics. Semiconductors, these are the transistors. They are used to manufacture transistors using silicon or germanium. To manufacture diodes, to manufacture transistors. Transistors in electronics are the switches, the digital switches we use in our today life. The use of a transistor is to switch on. Even a TV works on, it switches on using a transistor. Once a transistor is in a forward bias, an electronic gadget can switch on without a press or on off. Just use a remote to switch on a transistor and the TV will switch on. Have you ever experienced this? That once you press your remote to the TV, remember you have not switched on the TV. The TV is having a red light, meaning it is in a standby. Now, you press your remote, the TV will come on. Now, what has switched off the TV? You're in space, the TV is far from you, but only a remote control can switch on the TV and can switch off the TV. It is because of the use of the transistors, the digital switches. Now, these semiconductors are used to manufacture integrated circuits. Integrated circuits, we mean ICs. Most people knows it as ICs. As we hear, this is now electronics. My TV has blown out. My phone, the IC is heating up. My computer, the IC, okay? ICs, these are the random access memory. Wow, those are all ICs, integrated IC or integrated circuit. IC in full is integrated circuit. Integration means you bring a diode, a transistor together, a resistor, okay? A lot of electronic components, combine them together, connect them together like this. If this is a diode, connect it, this is a diode, connected to a transistor, and a transistor connected on the resistor, and the resistor is connected on the coil. Okay, now if you cover it and this leg is for a transistor, this leg is for a diode, this leg is for a coil, this leg is for a transistor, this leg is for a resistor, this leg is for a diode. Okay, now this one, once they cover it with a small sheet, inside has a connection, and this connection, the legs come out. It becomes an integration of electronic components, which we call an IC, with very many legs out. And these legs are the connection of the transistor, diodes, coil, resistors inside the integrated IC or integrated circuit. The same thing, the same semiconductors are used also to manufacture solar cells. They are used to manufacture solar cells. Okay? Now, these solar cells, let me rub off so that you see very well. Solar cells Solar cells are manufactured from silicon or germanium. Okay, mostly silicon material. You see how we have solar panels because of these semiconductor materials. Because these materials, solar cells, they are used to manufacture a solar panel, whereby during day this solar panel create the sun hits the solar panel creates electricity. At night, this solar panel, no electricity is created, meaning it is an insulator. It has no use at night, no production of electricity. Okay, and during day it is a conductivity to produce electricity. At night, I think it will act as an insulator because it has no use. Semiconductors still, they are used to manufacture microprocessors. Microprocessors, these are the processors in the computer. These are digital electronics. Processors like RAM, random access memory, ROM, read-only. Okay, these are all processors. CPU, these are processors. CPU. Okay, now CPU is central processing unit in the computer. Is the brain of the computer. And this is how we have come up to understand the conductors, the insulators, and semiconductors. Hope we are moving at the same pace with you. We are moving slowly, but I want you to understand these terms because we are going to be using these terms when we are now starting the real electrical wiring in installations. Okay, and this is the semiconductors, the conductor, and insulators. Thank you for watching this video. If you find this video useful, please, you can subscribe, share with your friends and students who are willing to learn electrical installations, and your family members who are willing also to join electricals. Thank you. Let me see you in the next video about the electric charge or electric current. Don't miss these videos. They are so much helpful in your day-to-day lifestyle. Thank you. See you there.